A monopolistically competitive firm faces the following conditions. P equals 20,000 minus 15.6Q, and cost is given by C equals 400,000 plus 4640Q plus 10Q squared. The question says, determine what should obtain under these conditions in the short run and in the long run. In the short run, the problem is exactly like a monopoly problem. We set marginal revenue equals to marginal cost. The marginal revenue will slope twice as steeply as the demand curve, or the inverse demand curve. So the slope of 15.6 on the demand curve will become 31.2 on the marginal revenue curve. To get the marginal cost curve from the total cost, we need to differentiate that equation. So the 4640Q becomes 4640 in the marginal cost equation, and the 10Q squared becomes 20Q. So that the marginal cost equation will be 4640 plus 20Q. Setting the marginal revenue equal to the marginal cost, we get 51.2Q equals 15,360, which says that Q equals 300. Plug 300 back into the inverse demand equation, 300 times 15.6. Subtract that from 20,000, and we come to a price of 15,320. Price times quantity gives us revenue, and the profit is $1.9 million. Graphing the problem yields the following. The marginal revenue curve sloping twice as steeply as the demand curve, intersecting at the midpoint on the horizontal axis, 641, which is half of where the demand curve intersects the quantity axis. You can see that this graph is not to scale because our marginal cost curve starts at 4640, which on the graph looks very close to 0. And you can see that the marginal revenue is equal to the marginal cost at a quantity of 300. Project onto the demand curve, and we get a price of 15,320. I've also noted the marginal revenue, which is equal to the marginal cost at 300, and that value of marginal revenue and marginal cost is 10,640. The challenge now is to add the average cost curve to the analysis. On multiple occasions I've said that we should not attempt to draw the average cost curve unless we have to, because we cannot draw the average cost curve accurately. This is because the slope is changing at every point, and it's virtually impossible to come up with the accurate average cost curve that is going to be U-shaped. The points of interest, however, are the turning point on the average cost curve where the slope is 0, the average cost value at Q equals 300, and the points on the demand curve where the average cost is equal to the price, also known as break-even. These are 4 points that will be of interest, and whenever we have to sketch the average cost curve, I would always advise you to find the turning point, or the minimum average cost, and also to look to see where the average cost curve intersects the demand equation. Along the way from the minimum to the demand equation, notice that the average cost curve has to cross the marginal revenue curve in this particular analysis, and it crosses twice. So in future I would ask also that you identify the point where the average cost is equal to the marginal revenue, and we have 2 of those points. To obtain the intersections of price equal average cost, we effectively set the demand equation, P equals 20,000 minus 15.6Q, equal to the average cost equation we see here. Or better yet, we can multiply the inverse demand curve by the quantity to get the revenue, and then equate that to the total cost equation. In other words, we're multiplying the average cost by Q, and we're multiplying the price by Q. So revenue equals cost, or price equal average cost, is exactly the same equation. When we calculate price equal average cost, we get these 2 break-even points, and the quantities there are 25.85 and 574.1. Of more relevance is the average cost at 300. We've done this problem before, and it looks as though the average cost, when we plug in quantity of 300 into the equation, AC equals 400,000 on Q, so that's 400,000 divided by 300. That gives us 1333.3 recurring, plus 4640, plus 10 times 300 is 3,000, so we have 7640, plus 1333, and that gives us 8933.33 recurring. We've already established that the profit is going to calculate at 1,904,000. And notice that the rectangular area between the price of 15,320 and the average cost of 8933.3, or the area I've labeled as alpha plus beta, the rectangular area, alpha plus beta, will be a value of $1.904 million. Recall the original problem asked us to determine what should obtain in the short run and in the long run. This means that we need to define what is meant by the long run. Notice that our chart here tells us that the performance in the long run would be a normal level of profitability. A normal profit in economics is a fair rate of return, a comparable rate of return to another investment, the next best alternative. So we would expect the economic profit to be zero. So there's a normal accounting profit, but zero economic profit. What we would expect then is that that $1.9 million would have been a short-run profit, and something is going to transpire in the long run that would cause that profit to go away. The way we define the long run in this case would be a function of time. Over time, other firms, seeing the firms that are in the market earning approximately $1.9 million, will, because of ease of entry, enter this market, and firms will continue to enter until the profitability goes to zero. And this occurs because the demand for each firm that already exists will fall as more firms enter. This is not a difficult idea to conceive. Suppose you were the only firm operating in a given location and you're making a wonderful profit. Someone else sets up business next to you. Customers don't care from which store they purchased the product, so you get half of the customers now, and your competitor gets half of the customers. The demand at your store has fallen by 50%, and if other firms continue to enter, then based on the number of firms, you can see that the demand for your store's product is going to fall substantially. So this is what happens as other firms enter the market over time, that the market share to the first set of firms will diminish, and eventually all firms will be the same size. That's an assumption of our theory. We're going to have identical firms, all the same size, but all making zero economic profit. So we show this by shifting the demand curve for each of the existing firms inward to represent the smaller share of the market. And this shifting continues until we reach break-even at price equal average cost, and there is no possibility of profit. This takes us to a point of tangency. The demand curve is going to shift inward until it's tangential to the average cost curve. So graphically, here's what it looks like on the demand side. The demand curve, the new demand curve, will be D prime or demand prime, and that's going to be shifting to the left. The marginal revenue curve, of course, shifts along with it because it always slopes twice as steeply, sort of like a shadow to the demand curve. It's always attached to the demand curve. The marginal cost and the average cost conditions are not going to change because nothing is going to change for the firm on the cost structure side, and therefore the new demand and marginal revenue curve are going to intersect the old average cost curve at some lower quantity, and of course a lower marginal cost. We said that the demand curve will continue to shift inward for the existing firms until there's a point of tangency with the old average cost curve, or the sole average cost curve. So here we have the average cost curve again, not as smooth as it could be, and the demand curve has shifted in until it reached a point of tangency, which means there's only one point at which the new demand curve is going to touch the average cost curve, and that will then give us the price at quantity 125 and a price 90.90. The profit is going to be zero. Notice the way we solve this problem is we find the slope of the average cost curve and we set it equal to the slope of the demand curve. The intercept on the demand curve is going to change when the demand curve shifts inward, but we are going to assume that the slope is going to be the same. There is not a strong case as to why this might be, but because there's so many firms in the industry, we are making this simplifying assumption that the demand curve shifts in parallel to the old demand curve, and therefore the slope will be the same. So remember the slope was minus 15.6, and now we calculate the slope of the average cost curve by differentiating the AC equation, and we get minus 400,000 on Q plus 10 equals minus 15.6. So the slope of the average cost is equal to the slope of the demand curve at Q equals 125. The price is obtained by plugging 125 into the average cost equation. So we're going to have 400,000 divided by 125 plus 10 times 125 plus 4640. So go back to the average cost equation, and we're going to plug in plus 4640, which is missing from that last line, and that gives us a price of 90.90 and a profit of 0. In the long run then, firms will enter until profit goes to 0, and each firm will set the price at 90.90 and the quantity at 125.